Okay, it's now been recorded. Okay, I will start again. Okay, uh, we stop at the develop the truth table. Based on the advice, my advice is please try to memorize all the truth table. For example, negation. Ada lagi nak masuk, aduh. Okay, negation. This small truth table part you must try to memorize. So P, if P is T, what is negation of T is F. If F, then T. This one you should memorize. Conjunction also the same. I don't want to repeat. You just read it. You just read it. Okay, this is the properties that you must obey. Disjunction or implication. Okay, this one I want to touch more on this afterwards. And lastly is the biconditional. Mana biconditional? This one. When only two proposition exhibits the same true value, then it's true. If some of it are different, then it's false. So that's why TT, same true value is T. FF, same true value is T. Otherwise, false. This one you must again memorize. Okay. We go back to the conditional. This is very special. If P then Q, P implies Q. P, the condition, some say antecedent. Alah, macam mana ni? All right. Okay, P implies Q. Okay. P is the condition. In some say antecedent. Okay. Antecedent. Q is the conclusion, or known as consequent. So that's why P, we always have the word if there. If P, then Q. So all of you are computer students, so you should know the decision variable, the decision. If P happens, then Q. If P not happens, then something else happens. So this is very important. Oh, the note say P is called hypothesis, Q is called conclusion. Up to the person lah. I don't like to use the hypothesis. I more like the condition. That's why the word's conditional. Okay, as given there is the properties. If T, only when T, Q, F, then the implication is false. Otherwise, true. That is very clear. Okay, this part, they say if P, Q, P is sufficient for Q, Q if P. Okay, all of this thing is different way of English saying P implies Q. That is their way. Actually, all of this means P implies Q. If I'm the person who teach this, I don't want to complicate you guys, my students, with the English. English is English. This is logic mathematics. If I'm the person, I will only teach my student by using if. If must be there. Kalau if tak ada, if there is no if, P then Q, that is not very clear. I really like for my students to use if something, then something. I will not try to trick my students to use, for example, 10. Q whenever P. Actually, it means if P then Q. Like I said, this is not English. So if I'm the person who teach you this, I will stick to if P then Q. Alright, I hope I'm still clear on this matter. Alright, example. If Zarif love DMA, then he will get 100. It's similar to, they just changed the English structure. I don't like to ask you that, seriously. But all of this means if Zarif love DMA, then he get 100. That's all. Not very tricky. We go to this kind. Okay, this one I need to teach you one by one. Okay. In the implication or conditional P implies Q, we call this form conditional or implication. However, this statement can be changed into different kind of representation. For example, converse, Q implies P. This time, Q implies P is not the same anymore with P implies Q. We call it a converse form. Contrapositive, not Q implies not P. It's known as contra. Okay. And it's stated there that same true value, P implies Q, has the same true value with not Q implies not P. It claims. After this, I will try to teach you. Actually, Miss Anis already did some videos. Please watch her videos as well. I'm just trying to clarify the content only. Okay, P implies Q, is it logically equivalent with not Q implies not P? Later we will check. We will check by using logical equivalence. All right. The last one is not P implies not Q. Inverse. Okay. Now, we try to do some examples. If let P is Iqbal, admit again. Iqbal not wear shirt. Sorry, forgive my English. Then Q, Iqbal sexy. All right. What is P implies Q if we transfer it into English? It's very easy. You just can say, in English, it says that if Iqbal not wear shirt, then Iqbal sexy. This is P implies Q. Very easy. How about if we try to do this into a converse form? Q implies P. What will it be? You just changed it. Is that if Iqbal sexy, then Iqbal not wear a shirt. Okay, let's look at the practicability of the logic of this thing. Number 1 and number 2, is it the same? Try to think. If Iqbal not wear a shirt, then Iqbal sexy. Oh, that's logic. If Iqbal sexy, then baru Iqbal tak pakai baju. Then Iqbal not wear a shirt. It's totally different thing in terms of the context. Alright? But still, this is a converse form. That's why P implies Q is not equal to Q implies P. Let's try number 3. And as you can guess, it is not Q implies not P. Try to change into English. If Iqbal not sexy, then Iqbal wear a shirt. You see, this time, contrapositive involves not. So in the normal context of the question, they usually don't give you the not. So I advise you to do not first. What is the negation of P? And what is the negation of Q? So that's very simple. Q, Iqbal, not sexy. Same goes for the not P. Not P is Iqbal, wear a shirt. Dia bukannya not lah, there is no not there, wear. Alright. Lastly, you buat sendiri. Not P implies not Q. Do this on your own. But still it's fairly simple if you already have the not P and the not Q ready. Okay, any question for the time being you may ask? Or maybe my example is not that appropriate, maybe. But forgive me, sometimes I like to use the example that I just get some idea. Okay, no question. Is everyone clear? I hope so. If not, I'm still waiting 10 seconds for the question. Okay, I hope that you managed to do not P implies not Q. Okay, we go to the next section. Okay, this one we already go through. This is about the precedence of logic operator, where I advise you to include as well bracket. Do things in the bracket first. Itu saya dah ajar 2 minggu lepas, last 2 weeks. This one, can you do this? I don't want to use this example. This one you try to do alone. I want to go directly to this part first. The development of a truth table is very important. There is a basic necessary skill, because if you manage to do the truth table very well, after you memorize all the 5 properties of the truth tables, then you can do logical equivalence. Okay, we go. Just now, okay, this is some of the context. Tautology, contradiction, contingency. This one later I will go back. Terus okay. Tautology, if all the column of the truth table exhibits truth value. Right now we only have one proposition, therefore 2 rows. TT, then it's tauto. But if you have P and Q, then you have 4 rows. Those columns need to be TT, TT, tauto. Baru tauto. Then it's tauto. If all of them is FF or FFFF, then it's contradiction. If there is a mixture between T and F, it's known as contingency. Very simple. It's just properties. Now we go to a hard part right now. Logical equivalence. Just now I said to you, P implies Q is claimed to be logically equivalent with not Q implies not P. So if Iqbal not wearing a shirt, then he's sexy. Is logically equivalent, has the same meaning as if Iqbal is not sexy, then he is wearing a shirt. It sounds different, but it holds the same logical meaning. So let's try to prove whether it is actually equivalent or not. Okay. Start first by developing a truth table, PQ. Then combination of TTFF, TF, TF. Alright. Next, what is P implies Q? I focus on the left part first. P implies Q. Ingat ke belum? Memorize already? P implies T is T. T implies F is F. F implies T is T. And of course T. So this part settled. Go to the next part. Oh, you have not Q, you have not P, and you have the arrow implication. Which one you should do first? And based on the logical order of preference, you must do not first. So not Q, F, T, F, T, not P, F, F, T, T. Okay. Next, I need to do not Q implies not P. So when you do not Q implies not P, please focus on this column. Nothing else matters. Nothing, no column matters except this column. F implies F, T. T implies F is F. F implies T, T, and T, T, T. So we just finish color line. We just finish, sorry, this one and this one. Sekejap. Alright. Okay, how to determine whether this proposition is logically equivalent? There's a way. We read the definition first. Sekejap, mana ni? Okay, the compound proposition are known as logically equivalent if the biconditional between those two propositions is tautology. Just now you know that tautology if that all the columns at the truth table exhibits true value. Based on this context, it states that this part and this part is logically equivalent if the biconditional between them are tauto. So let's look whether the biconditional between them are tautology. Okay, I maybe don't have really much space there. I'm trying to optimize this. It asks for if whether P implies Q, biconditional between not Q implies not P. This is what it means. We need to check whether it's a tautology or not. If it's a tautology, then it is logically equivalent. So T, T, apa dia? T. F, F, T. T, T. So it's tautology. So my conclusion I can say here, as this P implies Allah, P implies Q, biconditional with not Q implies not P, is tauto. What I can conclude right now is that this P implies Q is logically equivalent with not Q implies not P. It's logically equivalent, confirm. Okay, you get the idea. So right now, why not? You try to test yourself very quick, while I'm taking some break. Try to verify to me this one. Maybe very simple one. P or Q. Is it logically equivalent with not P or not Q? Very easy one. Okay. Can you test this? Is it logically equivalent? P or Q? Is it logically equivalent with not P or not Q? In 2 minutes, I want to hear your answer. Sir, I don't see your screen. I don't know. Tak nampak ke? Someone don't see my screen. Can someone reply? Can you see my screen? Oh, now I see. It's maybe your internet Habibullah. Maybe. Alright. Focus back. Try to check me whether P or Q is logically equivalent with not P or not Q. In 1 minute to 2 minutes, I want to know the answer. Thank you. Let me take a break. Okay, now I'm back. I just want to know whether it's logically equivalent or not first. Someone respond, please. Is it logically equivalent or not? Okay, Azizi said not logically equivalent. Can you show me your answer? Thank you so much, Anand. Thank you, Yong. Can you show the answer? Atau malu? Janganlah malu. I just want to see very quickly. If you feel shy, personal WhatsApp. Just take a picture, put in the WhatsApp. Can you do that? Letak dalam, take the picture of your solution, put in the WhatsApp list. I'm waiting. I repeat. Take the picture of your solution. Okay, thank you. Okay. Let me check. I just want to see. TTO. Seorang cukup. Okay, enough. Thank you. Thank you. Not PF, FFTT, FTF3. What is P? Okay, TTFF. Okay. Oh, Azizi, hantar balik lah. Tak payahlah padam. Alright, there is some. Okay, if you look at the WhatsApp, Ade Abdul, okay, both of them, okay, a little bit different in terms of their answer, okay? Both of them are doing the starting working correct. Okay, if you look at, I don't show at the screen, please look at your own WhatsApp, lambat. Okay, Ade Abdul does not do the biconditional part. And you don't put the conclusion. That's very dangerous. Please put the conclusion at least. For this part, if you don't put, is it logically equivalent? You don't answer that. That's very dangerous. You must at least have your conclusion. It is not. Kena tulis, You must write it. It's better if you do the biconditional part, like Azizi did. This is a more complete answer, and it follows the definition where it states the biconditional between those two propositions is not tautology. Therefore, it is not tautology, therefore it's not logically equivalent. But I can accept Aziz's answer anyway because he says it's contingency. So it's very well understood already that he understands. Okay, I will go back to this part. I'm explaining what happened. Just now, your friend's answer, both of them are slightly different. I'm sorry, nama Adnan. Oh, sorry, forget it. It's okay. This one, some students sometimes forget this part. This part they think is not important. But like I say, if a student manage to do this, then it will be a perfect answer. They show this red color part, they say it's tauto or not, then conclusion, that is the best answer possible out there. But some of my students, they realize this, second best answer. They say that this one, same. Therefore, it's logically equivalent. Some of you guys might do that, actually. They don't do the red color part, they only do the until the blue color part. They say this same. They write it same. Then they write the conclusion. Sometimes I accept this because theoretically, practically they are true. Because the biconditional part stems at the concept of the same truth values anyway. So if the students do the blue color part, maybe sometimes I still accept the answer. But the important thing, of course, with conclusion lah. If you don't have conclusion, of course you lose mark. So I hope you understand what I said. The red color, if you do until red color, is the perfect answer. The blue color is the second best answer that I may accept or not accept. Depends on the total marks. Alright, so this one is confirmed. It's not logically equivalent. So what is the symbol of not logically equivalent is this. You put a stroke at that part. Settle. We go to the next part. Okay, this one, please do the exercise. Determine whether it's a contingency, blah, 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 whether it's a logically equivalent by using a truth table. If you have 3 P, Q, and R, therefore you do 8 rows. Okay, we go slightly a little bit on predicates. In grammar, in English, not grammar, in English, I just want to say earlier first. If someone have class at 2, you may dismiss. If you have class at 2. If you're not, just stay with me. Okay, I continue back. Predicate. In English, you have predicate, subject, predicate. This thing I sometimes forget. So Yusuf is a computer student at UMP. So Yusuf is a subject. If you translate into a computer science student, there is just a variable. And some variable exhibit some characteristic where we call it as a predicate. Relate back with the set topic. Chapter 2, set. You, in any set, we define like this, right? A equals to X. Px. And I always put X in Z, for example. So this thing is the name of the variable on the left, the right is the predicate. The same thing, just different representation, alright? So imagine, for this question, ada jawapan, ada answer dah. Alright, let Qn be the predicate of n is a factor of 8. Let me put into the notation context. The variable is n. N is a factor of 8. Okay, tak habis lagi. Find the truth set of Qn if the domain n is a positive integer. So right now you have 2 different questions. The first one is a factor of 8, n is a positive integer. The second one is a factor of 8 as well, but the difference is that n is any integer. So this A and B might be different, and yes, it will be different after you try to list those. What is the truth set? The definition of truth set is the element which shows the true value. For example, I can ask you to verify like this. 3, is it an element of A? Of course not, because 3 is not a factor of 8. That's very clear. That's why if you put Q, Q3 for A first. Q3, the input n equals to 3. It will be false because 3 is not inside A. That's very clear. How about Q4? Q4 will be true. The reasoning is very simple. 4 is a element of A. 4 is a factor of 8. This is proof value, false true. But however, if I ask find truth set, truth set means the set must show all the elements which exhibits true value. 1 is true, 2 is true, 4 is true, 8 is true. True set all element which produce true value. That is the meaning. Huh? So same goes for B. The difference because that right now it involves negative integer as well. Because negative integer is still a factor. Eh? All right, enough about that. We go to, okay, this one, quantifier. Okay, later I will do a bonus lecture. I don't think that Miss Anis did this kind of lecture. I remember that I told you face to face about the table or the matrix of truth value before I teach you relation. I think I taught that, but again I need to do the video. So this one I skip for a while first. Huh? Let me show you directly to the last part of today's online lecture, which is the valid and invalid argument. Oh, sir, I have a question. Mana saya tahu, tak dengar. What is your question, Pravin?
Sir,
Yeah.
contoh kan ada PQR kan. Truth table.
Okay.
Kita tulis true, false ke true, false.
Okay. Is that your question? That's on your only question. Okay.
PQR.
Okay. Okay. Pravin asked about PQR. All right. Two version, according to his question, is that two ways to write. Okay, focus for a while. Usually, we write T, F, F. And for Q, we write 2T, 2F. And repeatedly T, F. Lastly is TF. If you do this very well, then you have all of this row has different combination, guaranteed. All of them are different combination. Pravin asked if someone like, can we do TF? My answer to this question is that you can actually, you are not practically, theoretically wrong, but you must make sure that your Q is not TF anymore. If you do TF, then I guarantee you will have the same combination. So you please don't do that. You must have different. Maybe you can TF here. You might also can TTT, then F. Okay, this is very important. Listen carefully to all my students. Although I say you can actually theoretically do this, but to enhance my speed of marking, I'm sure that you still get the same answer. Seriously, you can get it. The combination is wrong. The rightmost column will also be different, but still will be the same truth value. Just the different order. The order is different, but the truth value will hold the same. You can try that. But please, to make my life easier, I advise you, I don't mark this as a wrong. I advise you, please use this combination. Please use this combination. If not, I have 3 different answers that I need to compare for all you guys and will be very messy. Although you can do that, I strongly advise my student, please stick to the original number 1 order of columns to make sure that my marking is more efficient. All right, thank you. So again, if you use this method, senang ingat pun boleh. It's really easy to memorize. T, F, 2T, 2F, 1T, 1F. You just found PQR. What happens if you have 4? If you have 4, PQRS, Okay, this time you don't need to pening-pening. P, Q, R, S. You have 4. So how many rows that you should have? Is 2 to the power of 4. Is equivalent to 16. Bukan 8. So the combination. How many P? There are 8 P's. 1, 2, 3, 4, 5, 6, 7, 8. F, 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 F. Okay, tak muat. How many Q? 4Q. 4F. 4Q. Tak muat. R. 2T. F, F. T, T. F, F. T, T. Allah. T, T, F, and so on. S pula, TF, 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 and so on. Very systematic. I think this is much more cleaner. Start first with the large numbers of T first, then become smaller and smaller and smaller. That is for PQRS. If you have one more, PQRS TUV, okay, T, T. If you have anti-T, same principle. How many? So this one cannot be used anymore. You have more. It's 2 to the power of 5. Then it will be 32 rows. All right. Enough about the question. Thank you so much for the question anyway. It's very good to ask that because some of the students might do different kind of orders. We go to the valid and invalid argument. I will take 15 more minutes, I suppose. Okay. In any argument, you have premises and you have conclusion. Okay. Okay, this one, we start with the first one. If Yusuf is handsome, then he's an engineer. Yusuf is handsome, then Yusuf is an engineer. Again, in practical world, reality world of sense, some of you say, why is the relation? If you're so handsome, then he's an engineer. This does not make sense. Some of you might say that. Logic cannot determine the correctness or the accuracy of the info of the content. It just can say that the argument form can be used. It is logically, structurally correct. After this, don't say, why if Yusuf is handsome then you're an engineer? Tak ada kaitan pun. You handsome then you're engineer. There's no relation. But again, like I said, logic is the science to evaluate argument. It cannot show to you the correctness of the content. What can show you the correctness of the content is proving. So that's why logic must be associated with proving. After logic, you learn proof. In proof, by using the logically correct structure of argument, you can correct many things. You can prove many things to be correct or false. Okay, so remember what my saying is. Okay, we start first with the first example of argument. If Yusuf is handsome, then he's an engineer. Yusuf is actually handsome. Therefore, my conclusion is that Yusuf is an engineer. Is this structure logically valid? Can it be used for this kind? So, when you change into P implies Q, P, then conclusion Q. This kind of syllogism we call is known as modus ponens. It's a Latin word, I suppose. A method of affirming. There is also one more form of syllogism which is known as modus tollens. Method of denying. Not Q implies not P. You show not Q, therefore not P. In the next slide ada. Okay, what happens if I want to change this? Using the same example on the left, I want to convert it into English language. Okay. If Yusuf is not an engineer, then he is not handsome. This is the first sentence. The second sentence is that Yusuf is not engineer. As my conclusion, I conclude that Yusuf is not handsome. Macam tu. This is how you change it. Excuse me. Bas, no. Aku kelas. Okay, kita continue back. Okay, this is modus tollens. However, there are many kinds of syllogism. Okay, for this one, determine whether the following argument is valid or not by using truth table. And the question is how to determine whether the argument is valid or not. This is what you will learn. I'm show the simple example first. This is a very long one. PQ semua okay. Semua PQR. I show you the small one. Alah panjangnya. Okay, I need to repeat this. Okay, later I will use a different example. P implies Q. P, Q. Can this structure is logically valid? You do PQ first. Truth table. T, T, F, F. T, F, T, F. Then you must have P implies Q, P, Q. Later I explain. P, Q, T, F, T, T. P, although we already did P in the left, it's better for you to write again on the right. There's a reason is that to make sure that you can clearly see the difference between the argument and the conclusion. So this one T, F, finish. All of this has been inserted. This is the first line of the argument, second line of the premises, and the conclusion, right? Okay, this is how you determine whether the argument is valid or not. You must know first the concept of critical rows. What is critical row? Okay. The row which has all true premises. That is critical row. And valid if all critical row has true conclusion. So the first task you see that you must find the critical row first. That is your first task. That's why I arrange all the argument on the right and of course the conclusion at the rightmost. Based on this solution, okay, when you look at critical row, you might apa ni? Saya abaikan apa? You can ignore first the conclusion. Try to focus on the premises first. This is premises 1, this is premises 2. Which is the critical row? This is critical row. You see? TT. The second one is not critical row because it's not TT. You must find the row which has all true premises, and you only have one critical row, only this one. When you manage to find the critical rows, it is valid if all critical row has true conclusion. Then you look at the conclusion. And as this critical row provides true conclusion, therefore it is valid. So my conclusion can say like this: as all critical row, this is my reasoning, has true conclusion, what can I say is that this modus ponens is valid. Settle, counting. Alright, we go to the next example, again the short one. I try to create a question, a very short one. I want you to do together with me. P or Q? P or Q lagi, aduh. P and Q. I say not P. Implies Q. Not Q. Alright. This one, is it logically, is it valid? Logically valid? Okay, I open the slide for you to get the idea, but please do it together with me. I give you a head start. At least do the truth table first. At least do the truth table first. If you are faster than me, at least you can try to tell me, is this valid argument or not? Do this first. In 1 minute, then I catch you. This should be the last example for today, and I give you some time for Q&A after you do this. Okay, okay. PQ first, PTFF, TF, TF. What should I do next? Okay, I can do this from the top to the bottom lah. First premise first. P and Q. T, F, F, F. Not P first. Then Q. Okay, this one is quite tricky for some of you. Not P implies Q. You must work from the right to the left. Some of you might do some mistake here. Not P implies Q. You must read not P as your condition first. So F implies T. You must read from right to the left. F implies T is T. F implies F is F. T implies T is T. And T implies F is F. Be careful here. I double check. F implies T is T. F implies F is T. T implies T is T. And of course, T implies F is F. Finish. Next. Last one is not Q. Okay, not Q is just F, T, F, T. Okay. Is this logically valid or not? That is the last, main question that we should answer, by the way. Please distinguish first the premises and conclusion. This one is premises. This one, this column is not a premise. So please don't include it when you want to find critical row. P2, this is your second premise. This should be included in your critical row. And lastly is the conclusion. My point is right now, you can ignore this. You can ignore this when you want to search for critical row. You can close that anyway. But this not P is really important for you to develop the second premise. That's why it should be there in your truth table. But when you want to consider for the critical row, you can overlook this. Okay, where is the critical row? Focus on P1 and P2. This is critical row. This one. This one is not, this one is not, this one is not. So only one critical row. Is it valid or not? Then we look at the conclusion. As the critical row provide false conclusion, what can I say is that this argument is invalid. Any question? Oh, okay. I try to initiate a question first. Some of you might say, sir, I have, okay, let's look on the left. This one. This is a very good example when you have this kind of problem. You have 4 critical rows on the left. Tengok kiri sekarang. Okay, tengok depan sekarang. Okay. This example, a big example, has 4 critical rows. The popular question that the student asks is that, what happens if you have 1 critical rows which produce F? The first 2, oh, T. Oh, the third one is F. What happens, sir? Is it valid or not? We go back to the definition. Oh no, definition tu saya dah padam. Wait. Okay, just now I think I mentioned in the previous presentation, when the previous writing, valid if all critical rows has true conclusion. It must be all. If one critical row, only one critical row provide false conclusion, directly invalid. Okay, I hope that answers your concern for some of you who might has this kind of question. Even one day, if you have 4 critical rows, T, the last one is F, still invalid. Okay, that's all for the example. I give you 1 minute to think if you have further question. Okay, 1 minute. I will wait 1 minute for question. If not, our lecture will end after this 1 minute.